A very good morning to one and all present here. Today's my topic of presentation is about global positioning system. So let us see what is global positioning system. GPS, which stands for Global Positioning System, is a radio navigation system that allows land, sea, and airborne users to determine their exact location, velocity, and time 24 hours a day in all weather conditions anywhere in the world. In this slide, we will learn about the segments of GPS. As we can see, there are three segments of GPS. They are space segment, control segment, and user segment. Before going to the segments, we have to learn about GNSS, that is Global Navigation Satellite System. So, GNSS refers to a constellation of satellites providing signals from space that transmit positioning and timing data of to GNSS receivers. The receivers then use this data to determine locations. The performance of GNSS, that is Global Navigation Satellite System, is assessed using four criteria. They are accuracy, the difference between the receivers measured and real position, speed and time. The next one is the integrity, a system's capacity to provide a threshold of confidence and, in the event of an anomaly in the positioning data, an alarm. The third one is continuity, a system's ability to function without interruption. And the last one, that is the fourth one, is the ability, the percentage of time a signal fulfills the above accuracy, integrity, and continuity criteria. Now let us see about space segment. The space segment consists of a nominal constellation of 24 satellites that transmit one-way signals that gives a current GPS satellite position and time. It may be about 20,200 km circular orbit inclined at 55 degree with an 11-hour 58-minute period. Originally designated as NAVSTAR, that is Navigation System with Timing and Ranging. The first GPS satellite was launched in 1978. A full constellation of 24 satellites was achieved on 9th March 1994. Next, let us see control segment. The control segment consists of worldwide monitor and control station that maintain the satellites in their proper orbits through occasional command maneuvers and adjust the satellite clocks. It tracks the GPS satellites, uploads updated navigational data, and maintains health and status of the satellite. So in this slide or picture, we can see the different master stations and monitor control stations all over the world. And the third is the user segment. The user segment consists of the GPS receiver equipment, which receives the signals from the GPS satellite and uses the transmitted information to calculate the user's three-dimensional position and time. In this slide, we will learn about how GPS determines one location. Basically, it is done by a method called TRILATERATION. So here in this video, we will learn about trilateration.
How GPS works. Trilateration explained. Have you ever wondered how does the global positioning system work? I guess you did if you're watching this video. GPS uses a method called trilateration. It seems to be widely confused with triangulation, but triangulation requires measuring angles, while trilateration is based upon measuring distances. I'll show you this using a simplified two-dimensional visualization. Let's say we have three transmitters, A, B, and C. They form a triangle. However, they will be able to locate an object not only inside of the triangle, but anywhere in their range. So let's start by measuring the distance to the satellite A. I'll illustrate the measured distance with a circle. I'm not going to show you the receiver yet, because it will be easier to understand how GPS can determine your position without seeing you. So here we are. We've detected that the distance from the receiver to the transmitter A is equal to the radius of this circle. This means that our GPS receiver is located somewhere on it, but we need more information to be sure exactly where. Right now, it can be almost anywhere. Let's now measure the distance to the transmitter B. This should vastly increase our positioning precision. Now, the circles intersect in 2 points. This means that our lost traveler can be in either of these points. We're still not sure where exactly, but the third satellite named C should provide us with an answer. We're measuring the distance to the GPS receiver, and here we are. The three circles have only one common point, and if our detected distances are correct, this point of intersection has to be the location of our receiver. And it really is. Neat. But how does GPS actually measure distances? Let's see. GPS satellites constantly broadcast two pieces of information, their own location and their current clock time. Because the electromagnetic waves that are used to carry this information through the space travel at a speed of light, one can measure a distance using a stopwatch. Well, if it's quick enough to tap it twice in a millionth of a second with precision. Let's say that at this moment all devices, the satellite and the receiver, have synchronized clocks. I'll illustrate the time on a timeline. At the beginning of our timeline, every satellite sends out its own position and time. But before this information reaches the receiver, it's already outdated. I'll mark the arrival times with letters on the timeline. Now the receiver knows where and how much time away from it every satellite is to be found. Multiplying this by the speed of light easily gives us the distance instead of the time. Now, finding the common point of all three distance circles and taking into account the locations of all satellites will give us our own location. And this is how GPS is able to measure distance using a clock. Of course, in real world, this all happens in a three-dimensional instead of a two-dimensional space, so it's a bit more complicated, but the basic principles are the same. I hope you've learned something useful. Thanks for watching.
Hopefully you have understood about trilateration. Now let us see applications of global navigation satellite system. Basically, navigation satellite system provides us your current position, direction of the waypoint, distance, specified waypoints, speed, travel, direction. Moreover, it often shows us the sunrise and sunset time, time of day, heading and bearing, trip odometer, trip time, maximum and average speed, coordinates of cities and towns, and many others. Now let us see use of GPS in military purpose. This satellite navigation is applied to military mission for navigational purpose in enemy terrorists. and are especially important in absence of light in mission. The military force rely on GNSS over conventional compasses in order to obtain an accurate positioning of their own units as well as enemy's forces position and location of enemy's facilities or installation. The military navigation application in current use facilitate the following activities like force, forces location, forces navigation, forces deployment, all-weather around-the-clock operations, communication network timing. Next, let us see GPS navigation in the air. Like aviation throughout the world uses the global navigation position to increase the safety and efficiency of flight with its accurate, continuous, and global capabilities. GPS offers seamless satellite navigation service that satisfy many of the requirements for navigational users. It has some benefits like continuous, reliable, and accurate positioning information for all phases of flight on a global basis, freely available to all. Safety, flexible, and fuel-efficient routes for airspace service providers and airspace users. Potential decommissioning and reduction of expensive ground-based navigation facilities, systems, and services. The next one is mapping of Earth with GPS. GPS is often used to map the location of such facilities as telephone poles, sewer lines, and fire hydrants. The next one is about the marine navigation. The process of directing the movements of watercraft from one point to another, the process always present in some form when a vessel is underway and not drifting, varies with the type of craft, its missions, and its area of operation are done by the GPS. The next one is the public safety. Satellite navigation is fast becoming an industrial standard for location information used by emergency and other specialty fleets. Location and status information provided to public safety systems offer managers a quantum leap forward in efficient operation of their emergency responses team. The ability of effectively identify and view the location of police, fire, rescue, and individual vehicle or boats means a whole new way of doing this business. Some other applications are like hiking, biking, fishing, and many more. Hope you have understand about the global navigation position and its application. Thank you.